Hello everyone, in this video I'm just going to show you how you can print numbers from 1 to a given number using two ways. Okay, so one is the normal, the simple way, the traditional way. For example, this you're going to use let's use a function. All right, functions are very good. So I'm going to say void p, and I'm going to say while what's it? Okay, sorry, let's just use a for loop instead. For I in, sorry, this is in Python. Int I equals 0, I is not equal to n, and then we can say I plus plus. Perfect. Now I'm just going to see out I is not equal to n plus 1. Let's make it n plus 1 because that's going to include it. So we're gonna start at 1 because we want to print 1 till that number, so we're going n plus 1. Okay, so this is very easy. Forgot to just put the endl there. Okay, so let's just go ahead and call this function, and I'm gonna pass in a number like 11. So let's see if it prints 1 till 11. It should actually. And of course we forgot to put the semicolon somewhere here. So let's see. That's done, and you can see it definitely does 1 till 11 as we want it. Now this is one way of doing it. Another way is a really classic, or like a very interesting way with that only the big shots they use it, if you know what I mean. The coders, people who are really good with their coding skills, and that's using a recursive function. So question is, how do we do it using a recursive function? This is a bit, not many people understand recursion, the concept of recursion. Recursion is a concept where you call a function within itself. All right, so we can do it using a recursive function as well. So this is p till n. Now I'm going to just put an if statement here. I'm going to say if n is equal to 0, all right, then what I want to do is I want to return. So I want to cancel. We need to have this recursion because this condition, because if we don't have this condition, this if statement, then this loop or this recursion where we call the function within itself all the time is going to be infinite. So we don't want infinite loops, we want it to stop. So I'm going to put here n minus 1. So I'm going to pass inside of p right over here. I'm going to pass in an 11 because I want to start at 11, or sorry, not start at 11, I want to print 1 till 11. All right, so if n is equal to 0, it's going to return me something. It's not going to print. So where do we actually print something? Print it over here. All right, cout what's it, cout n, I think it, yeah, n, cout n and endl. So this is a recursive function. So let me just go through how this works. We pass in 11. Okay, it's going to check if 11 is equal to 0, which is false, so it's not going to do anything. It's going to go to the next line simply, and it's going to say 11 minus 1. So it's going to call this function itself again. So here n is equal to 11. Okay, and because n is equal to 11, let me just, by the way, use a little bit of a smaller value like that. Or wait, let me just run it because I know this video is getting long. Some people are not here to delve in the deep stuff, they just want to get the answer. So for their sake, you can see that this is 1 till 11. This works using a recursive function instead of a loop. Now I think I might be wrong. I think recursive functions are better and more effective than using a loop in some cases. So that's why we use recursive functions. But now let me just tell you how this works. N is equal to 11. Okay, then we arrive here at this line where it makes it equal to n minus 1. So n minus 1 is 10. So it calls this function again, and now n is equal to 10. And remember that this line we haven't executed yet, so this is not going to execute yet. All right, so n is equal to 11. Because the when n was 11, that function didn't stop. We're going to put a dash next to it, meaning that this function is still running. Okay, it hasn't ended yet. Then we have n equal to 1, 10. Then we pass in 10 here, and it's going to check this condition, and 10 is equal to 0. No, it's not. So it's going to come over here to this line, and it's going to call itself again, but this time it's going to be 9, and of course it hasn't ended, so we put that in. Let me just make this a bit shorter, make a 3, and then it's the exact same thing. 3 there, 2 there, and now n is equal to 1 because we passed in a 3. Then n is equal to 1, it's going to check 1 is equal to 0, false, and it's going to come and call itself again, and it hasn't stopped executing. Now n is equal to 0, but when n is equal to 0, it's going to come here and call itself again, and it's going to see if is 0 equal to 0, that's true, so it's going to return, meaning it's going to stop the function. So this function has ended. That's why we don't put a dash in front of it. So once this has stopped ended, it's going to come back to the previous one. Okay, and it's going to come to the function where n was equal to 1. Now n was equal to 1, this function is done, this line is done executing, so it's going to come over here. So it's going to start printing from here. So it's going to print out 1, then it's going to print out 2, then it's going to print out 3. So it's actually printing out in the reverse order, if you know what I mean. Let's just show you by running it out. 1 2 3, see, so it prints 1 2 3, the opposite direction. If you want to print 3 to 1, what you just can do is just do this, put this in the other direction, of course, and you can see once. Let me just clear my screen, by the way. Perfect. Now let me just get this in, and there you can see 3 to 1, reverse order. So yeah, that's recursion.